Hey guys, Coach Dennis here. I am going to go over the valence electron assignment for you guys. So I'm just going to briefly go over some things, maybe do a couple examples of problems that generally people miss throughout the years. So let's get into that. So number one, why do fluorine and chlorine, who are in the same group, have similar properties? Remember, everything goes back to valence electrons from here on out. So that's going to be it. For number two, make sure to list those two elements that are there. Remember, if you're going to have similar properties, you're going to be in the same group. So 3, energy level. That one, just read through the notes. Same with 4. For number 5, so what I have found for number 5, most people are getting most of these correct. However, what I am seeing is I am getting 8 valence electrons for carbon. However, that is not true. Remember, how we know how many valence electrons an atom will have, it depends on the group. So group 1 has 1 valence electron. Anything found in group 1. Anything found in group 2 has 2. Groups 3 through 12, they can vary their number of valence electrons, so we can't really say exactly what they are, and we'll talk about that a little bit in our next unit, going over ions. However, groups 13 through 18, what you can do is cover up the 1 in your 13, 14, 15, so on and so forth. You cover up that 1, that's how many valence electrons you'll have. So group 13 has 3 valence electrons. Group 14 has 4, like carbon, has 4 valence electrons. Group 15 has 5, group 16, 6, group 17, 7, group 18, 8. But what I found why people are missing carbon and saying that it has 8 is the Grandmaster cheat Google himself. So if you were to Google how many valence electrons does carbon have, it comes up and says 8. So guys, don't always trust Google. Just know how to do it off the periodic table, because it's much faster. First of all, instead of typing up each and every single one of these, I can just look at the periodic table, bam, 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 have them all done. So just know what group you're in, how many valence electrons you have. So having that 8 there, when I was grading these, a lot of people were missing that just because they were Googling it. That's my assumption, because it didn't look like everybody was cheating off of each other, which I can see that happening, but everybody just kept putting 8. That is not correct. So this octet rule, and talking about an octet, that's going to come up in our next few units. That's going to be the main theme. But as for valence electrons, before it starts bonding, carbon only has 4. So make sure we're correct with that. So yeah, valence electrons, we just find that. We find the atom, what group it's in, and then whatever group it's in, it's going to tell us the number of valence electrons. For number 6, when I went through those, the energy level, remember your energy level, where you find your valence electrons, is going to be equal to the period it's found in. So the example of magnesium, if you look at magnesium, it's right here. It's in our 3rd period. So that's where we would find the valence electrons. Number 7, this is where I can tell a lot of people, especially if you weren't in class, because I went over these in class, were missing these. So what you do for these are what we call Bohr models, or atomic structures. And what you're going to do is basically do a simplified version of our atom. So I'll go over a couple of these. I'll go over argon, helium, and I guess I'll do potassium. So I'll do B, C, and F. And the reason I want to do argon and helium is because they're both noble gases, but helium's one of our exceptions to the rule, where what group you're in, you have that number of valence electrons. Helium actually only has 2, and I'll show you why. So whenever we're doing these, atomic structures, we call them Bohr models. First things you want to do is find the parts of your atom. So first we find argon on our periodic table. If you see it here, it's in the third period third period, group 18. So we get there. So remember the atomic number or the number on top, that 18, that is going to tell us, so the 18 in argon is going to tell us how many protons it has and how many electrons. Next unit, we're going to talk about how these electrons, specifically the valence electrons, move around. So this number is going to change a little bit next unit, but just for now, we're talking about neutral atoms. So if I'm neutral, I have as many protons as I do electrons. So proton-wise, we're going to have 18. As electrons, we'll also have 18 total. And I'm just going to write it off to the side just so you know that. And then how we figure out our number of neutrons. Remember, we round the mass. So here we have 39.9 for our mass. So we round that up to 40. So then we subtract our protons from that. So 40 minus 18, that gives us 22 neutrons. Now what I like to do is keep this center circle as my nucleus, make it represent that, and then I make sure I have as many energy levels as I need. So if you look, argon's found in the third period. Since it's found in the third period, I'm going to have 3 energy levels. Oops. Yeah, let me erase that. I have 3 energy levels, and also I want to change the color. So I have 3 energy levels worth of electrons. And remember, the electrons found on the outermost are going to be your valence electrons. So our first energy level, it can have a total of 2 electrons in it. So we put in those 2. And the reason why we know it's just 2, and I've explained this to those that are in class, is if you look at each period, the number of elements that are found in that period tells us how many electrons could fit in that energy level. So in the first period, we have 2 elements found in there. So that means in my energy level, I can have 2 electrons. Keep doing that. So we used up 2, so we got 16 left. So using that same theory, if you look at the second period, we have up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that's true for our third period too, because look, they just, they stack on top of each other right there. So in our second and third energy levels in our atoms, we can have 8 electrons total in those. So let's start adding them. So we have 1, 2, 3, 4, 5, 6, 7, 8. And guys, if you notice, I'm always putting them in groups. Electrons like to be in groups. I could go into why that is, but that would take more time than what we need. So we used up 8. So now we're on our third energy level. Remember, we can have 8 valence electrons in it. So let's add those. And that's all we have left too, if you notice. So there, we used up all of our valence electrons, and the ones on the outside are going to be our valence electrons. So we have 8 total, and one way to check yourself is when you look at your periodic table, you look at the group. So argon, it's in group 18, so it should have 8 valence electrons. That it does. The only one that doesn't in group 18, and the only exception really to the rule, is helium. It only has 2. I'll show you that here in a minute. So I'll go through potassium. So if we look at potassium, it's in group 1, period 4. So if we look at it, it has the atomic number of 19. So I'm going to have 19 protons. I will also have 19 total electrons. Ooh, that's a terrible 9. So we have 19, and then we look at the mass. We're at 39. We'd round it to 39. We subtract 19 from 39, so we'd get 20 neutrons. So we have what's in our nucleus. We know how many electrons we have. Now let's see how many energy levels. So we're going to have up to 4 right here. So I'm going to have to add 2 more circles. So now we add our electrons. So we can have 2 in the first energy level. So we have 17 left. We can have 8 in the second. And remember, the reason we know that is because of how many elements are in that period. Remember, periods coincide with the energy levels. So we have 9 left. So we're going to fill this other energy level. Well, don't mind that noise. That's just something going on in the pipes, it sounds like. So we got 8 that we used up. And then our very last electron, that's going to be our valence electron because it's on the outermost energy level. And then if you look, it's in group 1, so it should just have 1. Now, on to my last example. It's going to be helium. So if you look at helium, it's in group 18, but it's our one exception. The reason that we consider this still noble gas, so noble gas have full outer energy levels. So here with argon, we have 8 that fills it up. So that's considered a full energy level. But if you remember, in our first energy level, we can only have 2 electrons. Well, if you look at helium, it has the atomic number of 2, so I'm going to have 2 protons, which also means I'm only going to have 2 electrons. So that's why we can't have 8. And then if you look at its mass, it has a mass of 4 if we round. So then if we subtract 2, we have 2 neutrons. And remember, if these add up, these should add up to what our mass is. So then I add my electrons to this one energy level. And remember, only 2 can go in here. So this is considered a full energy level. So that's what makes helium a noble gas. Noble gases are non-reactive. They don't need any electrons. They don't want any. So that's why they're considered noble gases, is they're non-reactive. Now, once we get into the next unit, we'll start talking about how every other atom is trying to be like noble gases by getting a full outer energy level, or 8 valence electrons for the most part. The only elements that don't need 8 are hydrogen and helium. So the octet rule, that's going to be a huge thing here in our next unit when we talk about ions. But essentially what that is having a full outer energy level. That's making us non-reactive. Otherwise, we're going to either give, take, share electrons in order to get that octet. Hopefully this was helpful for those that are struggling with it, especially drawing out these Bohr models. So guys, have a good day and have a good week.